Hey, Mathsy people. I'm going to tackle our last lesson for, I guess what we're doing is distance learning deal. And you've just finished up that lab 13 where you went into probably, well, I guess in function and in polar mode. Though you can do this in what's the other mode on those things? You could do it in parametric mode too for drawing circles. We're going to get into more of this stuff in pre-calc when we do conic sections, and circles is a conic section. You can take a cone and you slice it straight across parallel to the base, then the cut section makes a circle. All right, so it's got a context that's kind of embedded in geometry. We're going to bring it over to algebra a little bit and talk about the formulas and whatnot. And I'll give you a quicker way to draw these things today. I think you'll like this. I think you'll love your calculator for it. Right. Okay. So let's talk about a circle. And I'm going to go back to our friend, the unit circle. So I'm going to put here the point, 1, 0, and here's our origin at 0, 0. That's our unit circle, a circle with a radius of 1. And when we were doing the whole, like, what's this point called out here at such and such an angle, we were giving its address as cosine theta, sine theta. And by extension, we were treating it like it was a drop of 90. We got basically a triangle. And because there was a triangle that's kind of just embedded there in quadrant 1, we knew that there was some type of connection with Pythagoras. Pythagoras would say that, x and y and hypotenuse, or in our case, r for radius, right? That x squared plus y squared equals the radius squared. A squared plus b squared equals c squared. It's the same thing. If we were doing this in complex numbers, we could have the same kind of setup. A goes this direction, B goes that direction. And then we've got our last part, which is like the modulus. It's like the distance that we did, the absolute value of a complex number. It's all the same exact kind of math. Now, the cool thing was if we were doing this with a circle, the radius was 1, and 1 squared is just 1. So we knew that whatever the values were, like let's say if we were at 30 degrees, square root of 3 over 2 squared, and 1/2 squared, it should equal 1. Okay? Just bringing in the trigonometry into the story here, we would get 3/4 plus 1/4. Yes, that's true. That's true. So we know that it works for triangles, but really, we can think of it in terms of circles. And this, my friends, is the equation of the unit circle. It's its algebraic equation for its unit circle. In general, though, if we're not on the unit circle, it's just a version of the Pythagorean theorem. X squared plus y squared equals r squared. That's enough to help you draw a circle. Now, if you want to, you can go and rearrange all the parts and solve for y. And then plug in, actually you're going to have to plug in 2 separate equations for y in order to get your graph to do the entire circle in a function mode. And I believe that you did that in lab 13. We're going to say phooey to that, and we're going to take a nice, cool little shortcut. So let's say that the radius was 5, okay? And then we go out there. That means the equation of a circle with a radius of 5, that, and this is important too, whose center is at the origin, would be this. If you want to see kind of a generic version of an equation for circles, it's going to look like this. X minus h squared plus y minus k squared equals radius squared. And there's our h and k all over again, where for this one, h and k equals the center of that circle. All circles I mean, the definition in geometry of a circle is that it's all points that are equidistant from a specific point. Point on this one would be the origin 0, 0. So it's kind of like you got x minus 0 and then squared, and y minus 0 squared equals 5 squared. Okay, so this is a clever way of doing it in terms of algebra. If you want to draw a circle, just tell me, what's the radius and what's its center? And that's all that I need to know. I can plug that stuff in, and my calculator will do the heavy lifting. Are you ready to see this? Are you ready? Now, take your calculator, turn it on. And then I want you to go to Apps, and maybe something that we haven't done before. Go down to mine's at number 4, and it says CONICS. Okay? Click on that. And what pops up is some choices here. Circles, ellipses, hyperbolas, and parabolas. We're going to pick number 1. This thing's set up with already with 2 different formulas. One is algebraic, one's more geometric. 2 formulas for drawing circles. And you can see number 1 looks like my equation up here. So we're going to choose number 1. I'm going to choose number 1. I'm not going to care about the color or whatnot. And let's get our calculator to draw this one right here. This is that there's a center at 0, 0. I already said that. So h and k both are going to be 0 this time. And this is radius squared. So we're going to plug in that r equals 5. Okay? H is 0, k is 0, r is 5. Enter and graph. And, well, there it is. Look at that. You can trace it too, and I'll show you all the way around the circle. It'll tell you all those things. And wherever you stop on that circle, I'm going to stop right there. You see that? Oh, it's hard. It's not going to focus. Focus! If I take those 2 numbers and I square them and I add them, I'm going to get 25. Why don't you hit pause and try that. Square negative 4.95722 plus 0.652631 squared and see what you get. Right? It's supposed to work, isn't it? Decimal points. Whatever. This is where we say, come on. Close enough? Is that close enough? Is it close enough for you? Yeah, it works. It works. So let's take another one. Where you want to move it to, right? Let's move that thing so that its center is, I don't know, at 4 and 5. So we're going to use the same setup, and h is going to be 4 and k is going to be 5. And how big do you want the circle to be? What do you want its radius to be? How about, I don't know, 4. Okay, no problem. You can do that. Graph. It moves the screen for you. Isn't that sweet? Oh, come on. And you can trace it, and it'll give you some points. 8 squared, 5 squared. It's just been shifted over a certain number of points, and you can kind of tell exactly where that center is, yeah, more or less. Yeah, you can. You can. So that's a really cool shortcut. Again, that's under CONICS, under apps, and you can do some of the stuff that's there in the calculator. Example 1 to be super easy. Example 2 going to be super easy. You just got to remember, this is the form. This is the form. So if it says x plus 2 in the equation, you know that h is negative 2. If it says y minus 4, you know that k is positive 4. You just got to remember that little trick. Everything's over on the same side of the equation now. R squared's on the other side of the equation with h comma k as the center. You can say you're welcome. Now, there is, I'll give you one look at one which might be a little bit more complicated. And that would be if you're missing something. If you're missing something. So example 3 is like that. I'm going to hit pause. I'm going to put that up on the screen and up on the board, and then I'm going to work it out. Okay. All right, first one I think is like cake. Okay, it gives us all the information. It says, hey, write an equation for yonder circle, and then really it wouldn't be too hard after that to just draw the thing. In fact, if you got graph paper and you've got you know, one of these things, shouldn't be too hard. Okay, graph paper and a set of compasses. But center at, well, this is h and this is k, and the radius we're going to end up squaring it, right? So our equation, we're going to have x minus -3 squared plus y minus -1 squared equals 7 squared. Clean that up just a smidge and make this x plus 3 and this one y plus 1. You can plug that right into your calculator and out it comes, right? You think, where in the world would that be? Well, we said it in -1, 2, 3, -1. Put a dot there, and then that's 3, 4, 5, 6, 7. We're going to have a radius that goes out, you know, something like that. All right, this one's a little bit trickier because it contains a point. And so, but we can use that information to figure out what the radius must be. So the center is at -2, 4. Okay, we can go x minus -2 squared and y minus 4 squared equals, that's the part we don't know. This part we don't know. Radius got squared. But we know that if we were thinking about like the picture, well, where's -2, 4? -1, -2, 1, 2, 3, 4. It's up here somewhere, right? And they got this other point here at 5, 2. 1, 2, 3, 4, 5, 1, 2. That's the center. That's a point on the circle. So the distance between those 2 points is the radius. Now, how do we find the distance between any 2 points? Well, we're going to use the distance formula. How does the distance formula work? It's the square root of, let's just make this simple, the x distance squared and the y distance squared. How far is it from here to here in the x direction? It was, because this is basically turning this into a triangle. Boom. 1, 2, and 5. So it's 7 in the x direction. How far did they drop down in the y direction? 2. Went down 2. All right, -2. The 2 gets squared. Whatever. We'll put that in there. Okay, so that's square root of 49 and 4. So it's got a radius of 53. Square root of 53 is the distance between the two of them. Cool thing is, in the formula, it's distance squared. So right here, then, we can go 53, square root of 53 squared, and we just call it, put a 53 there. You put a 53 there. That, my friends, is the formula. Now, if you're going to do it on your calculator, you need to make sure that you figure out what the square root of 53 is and plug that in for r. Okay? Because 53 here represents r squared. You get that? Okay, so then you can use your app and you can get it to draw the picture for you and approximately draw it on your paper. Let me give you one more, and we'll just talk through it really briefly, and then off we go. How do I do that? It's magic, right? Last one says, hey, we got a circle, and we measure its diameter. Well, actually, we measured 2 points on its circumference, I guess. So between those 2 points, and they're right across from each other, they are on the diameter, a diameter, I should say, of the circle, and they're at 3, 1, and 6, 3. And I almost always just like to get an idea of what that would look like. So I'm going to kind of do a real bad drawing here and say, here's one part, and then 6, 3. 1, 2, 3, 4, 5, 6, 2, 3, Okay, the circle is on there. It's gonna have to go like that or something. I'm really bad at circles. Okay, just bear with me. Now, what do we know about this? What can we figure out about this? Because we need to know two things, right? We need to know what's the radius, and we need to know where's the center. So we can plug that stuff into the formula. So which one's the easier one, really? I don't know which one you would pick, but I would say first, if I just find the midpoint of the diameter, I've found the center, right? The center is halfway between those two endpoints on the diameter. So let's find the midpoint. The midpoint is found by adding together the two x's and divided by 2 is averaging the x points and averaging the y points. So the midpoint here, it's halfway between 3 and 6, and it's halfway between 1 and 3, x and y. So 3 plus 6 over 2 equals 4.5. 9 over 2 is 4.5. And over here, it's 1 plus 3 over 2, that equals 4 over 2 is 2. There's our center, 4.5 and 2. So I can start plugging in some of that information. X minus 4.5 squared plus y minus 2 squared equals radius squared. Now, how do we find the radius? Well, the radius is the distance from the center to either of those 2 points. So we can use the distance formula now from the center, which we now know, to either 3,1 or 6,3. Yes. Okay, no problemo. What's the distance? This time, let's say, what's the radius? Okay, and we'll do the square root of, there it is, of 4.5, how far is that away from 3 squared, and then how far away 2 is from 1 squared. Okay, now actually if I want to fill this thing in and just put the r squared, why don't I just square both sides? And I'll plug in whatever that equals. R squared will equal whatever this doodah here equals. My calculator is happy to do all that for me exactly what way. If I just keep track of my parentheses, squared plus, this is stupid, but I'm doing it anyway, 2 minus 1 squared, enter, 3.25 is radius squared. 3.25. There we go. Now I figured the center out. I figured out the radius. I can write it as that. And then I can go apps, conics, circle, pick that form. H is 4.5. K is 2. And the radius is, I guess it's the square root of 3.25, which it converts for me. And then I graph it. And there it is. Right, the only problem is I can't really change the window or zoom it to see where it was on there, but I can hit trace and I can see where some of those points happen to be. Come on, just look at the thing. Come on, there we go. Okay, so you can scroll around the circle and you can find out in general where it is. It's got 4.5 and 0.19, blah, blah, blah. So, yeah, it looks pretty good. It doesn't cross the axis there, but it gets really, really close. Yeah, it's really, really close. Anyway, it's kind of fun, isn't it? Nice way to finish things off. There's with circles. I mean, what better shape is there than a circle, except maybe a hexagon, right? Sheesh. I mean, technically a circle is an infinigon. It's got an infinite number of sides, or it's as the limit of sides approaches infinity. But we'll learn about that in pre-calc. It'll all be good. Okay, that's it. Signing out for Algebra 2. Peace in the Middle East.